Hello there, my name is Dumsane. Today we are going to look at some easier ways to work with exponents. We can do this by studying the laws of exponents. I want you to understand the laws rather than to learn them off by heart. When you understand something, you will remember it much better rather than when you have to learn it. By the end of this lesson, you should be able to multiply with exponents and divide with exponents. First, let's check if you remember some terminology. This is called the power of 2. That is the base. And the 10 is called the exponent. We use the same terminology when dealing with variables. A to the power 10 is called a power of A. A is the base, and the 10 is called the exponent. Now, let's look at multiplying. How can we multiply powers together? How would you find the answer to 2 to the power 5 multiplied by 2 to the power 2 multiplied by 2 to the power of 3? Let's see. Remember, we said 2 to the power 5. It means that we have 2 multiplying itself 5 times. So therefore, they will have 2 times 2 times 2 times 2. And 2 to the power 2 will be 2 multiplying itself twice. And 2 to the power 3 will be 2 multiplying itself 3 times. Now let's remove the brackets. We'll end up with 2 times 2 times 2 times 2 times 2. 2 times 2, and the last one will be 2 times 2 times 2. If you count all the 2's together, we'll have 1, 2, 3, 4, 5, 6, 8, 9, 10. So we'll have 2 to the power of 10. Right, do you think it is necessary to write the multiplication out every time? Or can you see a pattern in the exponents that you could use? Can you say that 5 plus 2 plus 3 gives you 10? Now let's see. We could do this as 2 to the power 5 plus 2 plus 3, which will give us 2. 5 plus 2, it's 7. 7 plus 3 gives us 10. We can generalize what we have found from this example. In other words, we have just worked out our first law of exponents. When we multiply powers of the same base, we can add the exponents. This is important. The bases have to be the same. Now that we know the first law, let's use it. Can you find the answer to 3 to the power 41 times 3 to the power of 20 times 3 to the power of 12? The bases are the same. So can we add the exponents? Let's see. We said if the bases are the same, we simply add the exponents. In this case, that means we'll have 3 to the power 41 added to 20 plus 12. If we add all this together, we'll have 3 to the power 41 plus 20 gives us 61. 61 plus 12, that will be 73. Okay, can you use what you've seen in these examples to find the answers to a to the power m multiplied by a to the power of n? We have two numbers with the same basis. We added the exponents before, so let's do the same. Did you get a to the power of m plus n? This is the general form of our first exponent rule that can apply to any numbers. This says a to the power m multiplied by a to the power n, where a and a stands for any number. That will be the same as a to the power of m plus n. Right, we use the letter a here and here to say that the basis of the numbers must be the same. We use m and n to say the exponents can be different, although they don't have to be. Here's another example using algebraic numbers with letter symbols. Simplify x to the power 4 times y to the power 4 times x to the power 6 times y to the power 8. I'm sure you can do this very quickly. All we need to do is add the exponents with the same basis. Let's see. We have x to the power 4 plus x to the power of 6. So we add 4 plus 6. Y to the power of 4 and y to the power of 8. So we add 4 plus 8. That will give us x to the power of 10, y to the power of 12. Now how about simplifying this one? X to the power a multiplied by x to the power of b multiplied by x to the power of c. The bases are all x, so we add the exponents. Let's put down the base x. Now, what is the exponent going to be? Is it a, b, c? No, you can't multiply the exponents. Be careful. You must add the a, the b, and the c. So in this case, it will be a plus b plus c. This is its simplest form. If you could find a rule for multiplying powers, let's see if you can find a rule for dividing powers. Let's start with an example again. What is 3 to the power of 7 divided by 3 to the power of 2? We can write it out like this. 3 times 3 times 3 times 3 times 3 times 3 times 3 7 times divided by 3 times 3. We can cancel the factors like this. 3 and 3 cancels out. The 3 and the 3 there cancels out. So what are we left with? We're left with 3 and 3, 3, 3, and 3. So that means we're left with 3 to the power of 5. What did you notice here? Look at the exponents. We can subtract the exponents, which gives you 3 to the power of 5. We now know the law of division of powers. When we divide powers of the same base, we can subtract the exponents. Let's write this rule as a general statement in letter symbols. A to the power m divided by a to the power n, that will be equals to a to the power m minus n. You are ready to practice what you have learned in this lesson. In this task, you will multiply and divide with powers that combine numbers and letter symbols. Simplify. Number 1, 3 to the power 2, x to the power of 3, y to the power of 4, multiplied by 3 to the power of 5, x to the power of 3, y to the power of 2. Number 2, 5 to the power of a, x to the power of b, multiplied by 5 to the power of 2a, x to the power of c. In the next lesson, we'll apply these two laws to more examples. Until then, bye-bye.